Hey guys, I'm alive. Okay, we are solving a backtracking problem on rat in a maze. Okay, let us see the problem. What does it says? Consider a rat placed at and square 0, 0 in a square matrix of order n cross n, reach n minus 1 n minus 1 destination. All possible paths can that the rat can take to reach from source to destination. The directions in which the rat can move are up, down, left, right. Value 0 at a cell matrix represent that it is blocked and the rat cannot move to it, while value 1 cell matrix represent that a rat can travel through it. In a path, no cell can be visited more than one time. Repeated path is not valid. Print answer lexicographically sorted order. Yes, okay, got it. And example like this, there is a 4 cross 4 matrix, and we want the path to reach the source to destination. Okay, but only like where there are three cases when you can move. It should be in boundary, should not be across boundary, should be in boundary, matlab inside the boundary. Okay, then um it should the matrix of ij should not be like it should be 1. Okay, should not be 0. And if already visited, we should not go back to that if already visited. Here we want all the paths to reach our destination. Okay, we need all the paths to reach our destination from source to destination in all the paths. So we are applying backtracking. And in backtracking, what is this? It is a controlled recursion and pass by reference. So the output, or you can say path, we will pass it by reference ampersand path, so that we can change it in path only. We will not make new paths. Okay. See, this is one path you can think of. Blue one is another path you can also think of. Okay. Reach, you can go back to see whether other paths you are getting or not. The rat can reach the destination. Two paths when printed in sorted we get. Okay, sorted is not a that very much big deal. Now we'll make now we'll make the recursion tree. Okay. So we have to go n minus 1 to n minus 1, yeah? Let's solve it in geeks for geeks. Okay. We have a matrix and we want the path to reach the source to destination. So we are, let's say, have a 4 cos 4. So we'll pass it 3 cos 3 comma 3, the row and column, and we want path. So we have 4 things, 4 choices, and we have to take decision on that also. Okay, 4 we have 4 choices. One is down, up, left, right. 4 choices. We take one choice whether it is valid, where there is valid. Okay, we take one choice. Then again we have more choices like that. Again 4 choices, and we have to put it in visited. Put it as visited. So let's start the code. We have a vector maze. We need a row. Let's say, oh yeah, we need n also. Maze dot size. Let's say column. We need a vector. We have choices. Let us make a struct, or we can say class, called choice. We have name, string name, the name of the strings. We have name, let which can be D, yeah, up, left, right, int. Okay, so the vector of choice. Okay, obviously it should be capital. Let's write it by capital. We have the choice as up, dx would be, if you go up 0, um let's call it y. So dx would be -1, the same I think. Up, down, let's say. Up, down, left, up, down, left, yeah. Left would be 0, I think, -1. Right. Go to right, then I think +1, 0, 1. Was it is 0? Yeah, 1. Yeah, made it. We have made the choices. Now let us make the solve function. Pass x, pass y, pass n, pass path, pass answer. So we have x, y, n, string, path, and answer, and choices. Now the base case. If if x equal to -1, y equal to -1, that means it reached the destination. If it reached the destination, then answer dot push back path returned. Yeah. Also, here you can read an answer. And if matrix or maze of 0, 0, 1, then only you can go. See. Otherwise, return then return answer like this. Or return -1. It is not possible. Hmm. Like empty string, we can say. Empty, empty vector. No need. Okay. Now we have written the base case, obviously. Now we have to write the now we have to write the what do you call the choices and all, like for all choices. Okay, for auto वेक्टर में सारे चॉइस के लिए okay, we will see if it is valid or not. Okay, we need int new x, which will be x plus previous x plus the what do you call choices dot dx. I written now. This is dx, like x minus 1, like this. Int new y will be y plus choice dot dy. The change 1 or 2 for moving up or down or left or right. Yeah, we have made all the choices for dx and dy, and we have just make a new x, new y. If you move down or left, doesn't matter. It depends on the choice. Okay, either of them we are taking. Yeah, and if if is valid, if it is valid, new x, new y, and see what is the validation thing, that it should be in the boundary, inside the boundary, and it the next element should be 1. We need also maze also inside the boundary. Yeah, if it is valid, then only we can just um move. Yeah, we can like path plus equal, you can add into path what? The choice dot name. Yeah, we have to add the name. Oh, yeah, we have added the name, and um we can call for the rest. Answer and choices. We have we only think about on case now. See, we have all the choices down, left, all the choices. We have make the new x new y for all the choices. Okay, and if it is valid, if we can move, if we can move, if if can move, if we can move. Okay, if we can move, then we add the choice and give all this recursive function to do. For new x, it would be adding checking whether it is for added or not. Also we have to make maze of, did we have passed maze? Nah, we have to pass maze also. Okay, bro, no, bro. Okay, got it. And here we can put it. Nice. Okay, and what we can do, see, we can um write like the previous one, x and y is 0, like we have visited it. After solving all that, we have to revert back. We have to go back. We have to backtrack also. We have to backtrack also. Yeah. How to backtrack? We can do like we have added something. Yeah. So we have also, see, we can do like maze of x and y, again reverting back, so is equal to 1, and the original matrix, and path should be, yeah, minus equal choice dot name. Yeah, added, and we have to backtrack also. Nice. Now we have to write another function, whether it's val move, we can not pull move function, like we need int x, we have int y, we have maze also. This is the maze. Okay, and we have also what, n. Now when we can move, return when x is greater equals 0, new x is greater equals 0, and And or what to use? Say and because x for x less than n is for x. It should be valid. It should be between them. Okay. Also, y should also be greater or equal 0 and y should be less than n. That means it should also be between the boundaries. It should x and y both should be inside the boundary. Then only we can move. Okay, and also uh and because it is also should also be true that maze of maze of new x and new y should be 1. That means we can move. If already moved, we make it 0. If moved, we have moved. Let's say we have moved. Move now, let's say moved. Again, we have moved. Okay, moved. Let's first compile it and I will surely show you how to. Um, okay, what is the problem? Error with this. I think okay. Uh, yeah, I think we haven't done maze. Oh, we have added maze also, no? Okay. Um, so okay, we have made it public. Oh, yeah. We have to print it lexicographically or something. What? Hmm. How to see how to debug a problem. Pass state by reference only. Hmm. Mark choice member as public inside struct to simply since choice is a public member in the struct. So we can make a struct choice. Okay. We can make a struct struct choice and okay. So turn it, yeah. Oh, we want, I think, lexicographically. That's why. Nice. Previously, what was problem? Start. Problem is that, let me show you. It is not lexicographically arranged. Same, but it's here or here. So we have sorted it and pretty nice, pretty simple. So let us again try to understand what we have done. Yeah, let's understand what we have done. We have maze. Yeah, we have n. We have x. Yeah, we have a path, and we have answer. It's empty, for example. Choices. We have made a struct of. We have made a struct of choices. We have made a struct of choice. Yeah, which will have a name and dx and dy. Struct is always a public, or if you want to use a class, then we have to make a constructor also, and in the constructor you have to also you made the like choices, uh, dx, dy, all these things. Yeah, made a constructor and then initialize that. Okay, that's how you can make a like choices struct or something you can use. Okay, we have used a struct. Nice. You remember this thing that we have made a struct, we have made a like which have a name, and also we have the changes that how many difference it is doing. Like if you go up, then 0 to you get -1, changes is there. We add that changes to x to get into the position. If it is up, then the x like 0, let's say, and the change would be like the -1 in a row, and column would be same. In down, column would be same, plus 1 would be our what we call the rows. And if you go to the left, then the column will change to -1 and column will change to +1 if you go right. That is the what you call choices we have made. And if m of 0, 0, 0, 0, that means the first is not 1, then obviously you have to return empty, because it is not possible for us to do the solution, because if it is not put in the first position, how can we solve all these things? It's not valid. All right, now if solve x, y, and path, answer, choices, maze, and all that. Okay, so the solve function is here. Let's see what what we have done. So we have made x, y, n string, passed it by reference, which is not changing, and is not changing obviously. Passed it by reference because we are doing like adding all these things and reverting back. When we returning, we just what do you call, we make it as original. Okay, we make it as original, so do not need to make it another time like path. Okay, we should we're not copying it, we passed it by reference because we are backtracking it. Okay, and also we have answer where the answer will be stored, and the choices which is not changing, so I have passed it by reference. And maze, we have to make it like 1, then again 0, so we have to pass it by reference. Okay, then if it reaches the destination, that means x is n-1, y is n-1, then answer dot push back the path. We should push the path, and then you have to return. Then we have make a loop for auto ampersand what choices. Okay, choice, and it should move to the vector choices. Okay, now new x and new y you have made. If you move, yeah, we have, if we move, then the new x and new y would be the what x plus choices, choice, like up, like the up, down, up, left, right, all these choices you have. Okay, you have to choose one of them. You have four choices. So make a loop on the choices and make a x new y where you can move x plus choice of dot dx, that is the difference, and dot dy, the difference. Okay, uh nice. So yeah, yeah. So it should be like when we can move. Yeah, when we can move. When we can move. In this condition, that it should be inside the boundary. When we can move, it should be inside the boundary. That means x greater or equals to 0, less than n, y greater is to 0, less than n. All should be and. So all should be true. Then only we can move. Should be inside the boundary, as well as the it should not be repeated, and the it should be like the not visited. So what you have done, we have made like this thing and it's not visited, so we have make it 1. If it is 1, then we can move. If we have moved, then we have made the previous uh that element is 0. That means we have moved. Okay, we have moved. We will not repeating back again, so it will be loop. So we do not want the loop. That's why we are just making it 0. That means we have visited already visited. Then we add path dot pushback choice dot name. Yeah, if we do like the plus equal and all that, it would not work, because we are adding int and int, char and char, string and string, not like uh string and character. It's not possible. So we have to push back elements, because path is a string. To push back that element, we want to add, we have to add the string only. You can add the string, not the, or we can just typecast it to string, so possible. We'll see. Then we have make a solve function. We have called the recursive function for to do the rest of the work. Like for new x, new y, you have to make again the same things that it will do. It will do by itself. And before reverting back, like going backtracking, then we have to make it again 1, and we have to also pop back that element which we have already pushed in the path, because we have passed it by reference. We changed. That's all about this what maze in a rat in a maze problem. We'll be solving more problem on backtracking, like n queens and all that. Hope you like this video. Subscribe, share, and